morning, everybody, to my operations people, my developers, and my DevOps people. This is Serverless Ops, bye-bye bash, hello Go. The purpose of this talk is to give you some source code and some patterns that give you a more resilient model for testing your infrastructure in the cloud. So what we're going to learn and what you can take away from this is how to use the power of serverless to keep the rest of your resources running. Serverless is a great tool, but it's not the only tool, and especially for Go developers, we have a lot in containers, and we still have a lot on virtual machines that we need to manage. We also have other aspects of our applications like databases that we need to manage as well. And even in a purely serverless environment, you can have things happen like security incidents that you need to conduct a SIP on. This pattern will help you with that. I'll also provide a sample of testing your ops, including a pattern for Go that you can take away. It'll probably be well known to the developers, but the operations people might not have seen it. A pattern, a general pattern for orchestrating your workflow in the cloud. A complete application with source code end to end that's already published and available for you to both start using and start modifying. It's under the Apache license. And then we'll have a Q&A period. And again, the sample code, of course, since I'm from AWS, is on AWS. It's what I know. But this pattern is meant to be generic, and your cloud provider, as long as they provide events and the ability to consume events, some sort of workflow engine, functions as a service, and an SDK with Go primitives, then you should be able to apply this on that cloud provider as well. And again, the use cases that this is mainly, or the top three that we see are for security incident response, for disaster recovery testing, so you can test your DRBC plan, and for pre-production environment population, especially pulling your data out of production, snapshotting it, running it through a cleansing workflow, and putting it back into staging. So here's how we're going to go through today's talk. I'll be pretty quick about it. What happened to your shell? Yes, there are still servers. Why use serverless for ops and why it's a good fit? Why use Go for ops and why it's also a good fit, in addition to being a great fit for serverless? How to test our ops, the general pattern. That specific example is going to be an AWS Backup DynamoDB rotator, and I'll work you through that when we get there, and then the Q&A again. So for me, the things you probably care about most are that I'm a senior developer advocate on serverless at AWS. That means that if you have ways that you would like to see us improve all of the serverless services, I'm your direct route back to the product team, and I would love to hear your feedback. It also means that if you follow me on Twitter up there, you will see this type of technical content complete with source code for how to more effectively use the serverless patterns on AWS. So what happened to our shell? In the good old days, we could SSH everywhere, and that was great. And then we moved our servers up to the cloud, and we had to adapt the bastion pattern, right? So we were already abstracted away from our shell by one step. We had to pass through something else to get there because our instances were inside VPCs or private subnets, and we couldn't just go straight to them. And then we moved to containers, and it became a little trickier, where some patterns and some models you're allowed to access the shell, some you can't, such as Fargate, where it's running in a private network that you don't have that access to. And then we created patterns and workarounds like sidecars running only an SSH server. But when you get to managed services where your service provider is handling everything for you, you don't even have that capacity to shell in. Like there's no concept of shelling into a DynamoDB server to start running queries to see where your indexes are off, right? You have to give up that concept of the shell entirely, which largely means that bash goes away, which of course I argue is a good thing. But there are still servers. And yes, we hear this all the time. You can't call it serverless when there are still servers. There are. But when we talk about serverless, we mean four things specifically. The first is there's no additional infrastructure provisioning and no management of that additional infrastructure. And what we mean is we have a shared responsibility model with a customer at AWS, and we handle everything from your runtime down. That's physical security of the data center, power, hardware failures, operating system patches, hypervisor environment, libraries, OS patches, everything all the way up. All you're writing is function code for your customer. And when you're in IT operations, your customer is the rest of the business, right? So you're writing business value code for the rest of the IT infrastructure. Whoops. It scales automatically. That's the second characteristic of a serverless application. You don't need to think in advance, okay, what if I have a burst event and 100 of my instances fail at once instead of just one? Do I have enough to execute my DRBC plan at the same time. Your provider handles that scale out for you, and it's pretty much instantaneous. It, of course, takes some time, but it's much, much shorter than adding instances to a cluster so that you can deploy more containers and deploy more workloads. You pay for value, which means when you're not running, you don't pay anything. And when you're running, you pay for exactly what you've asked for. In addition to cost efficiency, this has some ecological efficiency as well. You're not consuming idle cycles of power. You're not burning electrons to do nothing. So it creates a greater efficiency for your apps, not just economic. And finally, it's highly available and secure. So when you think about things like high availability, and the way that we do it at AWS is through multiple availability zones, which are multiple data centers in a single region. You no longer have to think about a subnet here, a subnet here, and a subnet here. We deploy across all of those. If one of those AZs goes down, your application continues to run. So why is this a fit for ops? First, you've got enough stuff going on. And if you look at this chart, as you move up the bottom, you're moving up our shared responsibility model. And you probably have a lot of applications that you're already managing here, right? So you don't want to add that same level of complexity onto managing those applications, or you're getting yourself in a negative feedback loop, right? So with serverless, you can simply define your event, and all you're responsible for is that top layer. Okay, my backup completed, now I want to restore it over here, now I'm done. Not my backup completed, so now I want to invoke a Python 2.7 script. Whoops, that runtime's just been deprecated. Let me put it onto Python 3.6. Okay, that library doesn't work on this version. Let me update my operating system. All that stuff's out, right? So another good reason for serverless is that these tasks are irregularly executed. They might be regularly executed from the concept of like a cron job. For us, that's called CloudWatch events, where every hour, every 6 hours, every day, every Thursday at 2:55 a.m., whatever you define, that's still not regular across a week of full time, right? So you have these peaks, these spikes of traffic where you need a lot of availability for your operations. Maybe you restore an entire environment overnight, and then the rest of the day it sits idle. So that automatic scaling is a good fit. The other aspect of, or another aspect of serverless that makes it good for ops is that it runs inside the same platform as your infrastructure. Whoever your service provider is, you're running inside there with the same rules, the same service integrations, the same identity and access management model, the same permissions. You're giving it a native access to that you wouldn't necessarily have if you wrote something yourself and put it on an instance running all of the time. A lot of these tools that I'll show you take advantage of what we call service integrations, which is where the tool calls out to another service on the platform without you having to write any code whatsoever in it. So on AWS, that can look like an event coming in and you writing that event to DynamoDB without ever even having to touch a script or a binary. Now, yes, you'll have custom code that you need to put into your binaries and Go, but you don't have to write that every time. And the fewer of these that you have to write, the fewer of these you have to maintain, and the greater confidence you can have that over the lifetime of the service, this will stay the same. Because these are service level contracts, right? This is how the service works. So once the integration is set up, your operating system, your libraries, all these things increase in patch level or feature level underneath without you having to change it. So you're talking about years and years. Fine-grained access permissions. Again, the things that you can do with identity and access management in the cloud are extremely powerful, down to allow only this function to execute only this single API call on only this regular expression of databases, right? Even though another function may be able to execute that against a separate category. So it helps with separation of permissions and separation of responsibilities, and it allows you to get it down to the finest grain level, literally down to the table level or even to individual records within the table. So you could have a function that pulls out only your changed user data for the day and then scrapes it and wipes it out before you do that prod to staging cutover, right? And then that's the function where you have to focus the most scrutiny on your security aspects of it, because that's the one that has the most access. It also limits your blast radius so that if some other function gets malicious code or just executes incorrectly. It only has the ability to modify whatever you've explicitly given it permissions to. And a side note that's not on the presentation, please don't ever give wildcard permissions to your IT applications, right? It's so powerful and so dangerous. We say in general, don't give wildcard permissions, but really don't give them to your IT applications. Use some sort of patterning or pattern matching and know exactly what you're monitoring with it. And the last one is logging. In particular with Lambda, but with most of these functions, whenever you write anything out to standard out, you're getting that captured in your logs. It's not necessarily the case with Bash when you have it on an instance and you have an agent, but what if that instance gets moved or gets disconnected and the agent can't communicate to the log server? None of that is in play now. You write it to standard out, it goes into your logs. And that's however you choose to structure it. So if you use Logres or if you choose some other way of structured logging, that's just how it comes out. So why choose Go for ops? The first reason relates to what I talked about with those service integrations. There is a very long lifetime for Go, in particular in the cloud. When the designers of Go made that 1.x contract that anything written in a version of 1 would run in a later version of run, that was a very powerful statement for cloud applications where everything changes. You don't have this idea of deprecation. So if you, or at least on the 1 series. So if you wrote a function, and we have this running, if you wrote a function 3 years ago in Go and it's executing, it still continues to execute without any change from you. So you can have confidence that the investment in time that you make today is going to continue to pay out as you change your infrastructure without having to go back and recompile, rebuild, update libraries, all of this. The second feature is just a general feature of Go as well, but concurrency. There are a couple of ways to handle concurrency and parallelism within serverless workflows, but the native concurrency for Go is extremely powerful because you get typically events that have sets or collections of data. And then whatever action you need to take from an IT operations perspective is typically going to be an asynchronous operation or a long-running polling operation. So you can use Go routines to kick off all of those concurrently and then wait for the return, or you can put them into a queue. But the thing is, you don't have to step through them sequentially. You can allow the Go routines to make these asynchronous API calls concurrently. Another general feature of Go, type safety, but this becomes extremely useful when you're working with cloud infrastructure. When you write functions that expect an EC2 instance and they get called with a DynamoDB table, you already know that's not going to fit. And so the function just refuses to run. So you don't pay for this long-running execution time. It just bails and says, all right, I can't handle this because this isn't what I was designed for. It also means that you can natively access all the specific properties of your resources that you want to access and be guaranteed that they're there. And this is where I talked about having a type-safe SDK from your cloud provider, whomever that is, that enables this feature and these benefits. And the last aspect of why you should choose Go, I mean, we're all Go fans here, right? So it's just developer joy. The same tooling that you're used to, even if you're used to writing monitoring applications for Kubernetes, is going to be the same tooling that you use to write serverless monitoring and IT infrastructure applications. There's no additional tool chain that you're going to need to learn here. So, testing our ops, and of course I've scratched out apps because we've just stolen all of this from the application developers, so thank you for working out that problem for us. This is a major difference between handling your infrastructure in Go and handling your infrastructure in Bash. In Go, if you're not familiar with this pattern, you have receivers for functions, and these receivers can contain any number of information or pointers, et cetera, that you define. And in this case, what you want to put in there is the interface to whatever your service is, not the service itself. So when you call a function whose purpose is to take a DynamoDB backup and restore it somewhere else, you don't pass in the DynamoDB API, you pass in the DynamoDB interface. And you don't pass it, you use it as the receiver. And you do that so that you can mock that DynamoDB interface in your tests. So on the left here is an example of a Lambda function that takes Step Functions interface as its receiver. And then on the right is the example of the test. And you can see you have this mocked start execution that includes the Step Functions API and has a function here, start execution, that is a native function of the Step Functions API. But in our case, we're just returning a predetermined output so that we can test the behavior of our application. This is, I would argue, hundreds of times more important in operations than in development, application development, because in application development, typically your cycles here are going to be short running by comparison. If you have a long running task, it's a couple seconds. If you have a long running task from an operations perspective, it's several hours. And before I learned this pattern, yes, I would sit there and kick off something and hope that it worked. And 2 hours later, I would go back to it and realize that I missed a semicolon or something somewhere, right? That's not an effective development pattern. So this enables you to write test-driven code for your operations management, and it enables you to shortcut all of those long-running applications. And we'll do a Q&A here, but I want to, at the end here, but I want to stop and make sure this is clear for everybody, because I think this is one of the most powerful aspects of testing your operations in serverless. So if you have any questions specific to this slide, I'll take it now. Otherwise, we'll move on. And yes, all of this code is given to you at the end. Okay.
How do we make sure that the mock actually behaves like the real system?
Well, that's the classic test-driven problem, right? So the mock, because it's the interface, only allows the certain functions and signatures that are defined in the actual API. So it is up to you to provide the right return values inside that correct return type. But if you call the function with the incorrect signature, it will fail. So you have to call step functions dot start execution output and pass it a step functions. This goes off the screen, so you can't see the rest of that function signature. You will see it in the code. The input value is a step functions start execution input type, which is a very specific type with very specific fields. And the return type is a start execution output type, so the same thing. So if you don't return that type with appropriate typed values in the properties, then it will fail. It will be a compile time error. So that at least lets you know that the shape of your behavior is what's going to be seen in production. Any other questions only on the testing? Okay. So a general pattern for those 3 use cases that I talked about is to use a state machine to step through each step of your workflow. And we typically talk about state machines for us as business processes. But again, I go back to, if you're in IT operations, your processes are business processes. Your customer is the rest of the organization. So the first thing that happens is some event initiates your workflow. This is where I talked about your cloud provider generating events for you, or you can have like cron jobs or the equivalent CloudWatch events on AWS that on a schedule that you define, dispatch an event that kicks off a workflow. That workflow will do something, and because these are long-running tasks, it'll sleep. And then it'll go back and check for completion. And then it will repeat this cycle until it's done, and then it either puts the output somewhere, or more commonly, it'll just notify you on completion, right? The restore of production to test A was successful, or it dispatches an email saying this went wrong, and you need to look into it. So on AWS, our workflow management tool is Step Functions. Step Functions allow you to run for up to 1 year undisturbed. So one execution can start today, and then next year we can come back and see what happened with it. It allows you to interrupt for manual processes with a callback. So particularly in your security incident response plan, if you need an individual from the security team to examine something before saying, yes, take this offline, or quarantine it, or no, this is fine, put it back into production, then it sits and waits for that manual input. And that can take as long as you need it to do. It also has error handling, backoffs and retries in there, so you can lift that logic out of your functions and only have the functions do the single thing that you need them to do. Given this set of DynamoDB input, restore it to this DynamoDB table, right? And you don't need to worry what happens if you get an error. Return an empty object and an error, and let the state machine handle everything else. And then your function doesn't have to worry about its state. Is this the first, second, or third time that I've tried to restore this? All it needs to know is, give me this input, I'll do this task, and give you this output. And so it allows you to apply almost a functional programming mindset to your operations. Step Functions also coordinates multiple services into workflows. So the common thing you think of is a step function calls a Lambda function and then calls another Lambda function, but it also leverages those service integrations that we talked about. It can take some amount of data that you get and call DynamoDB. It can take some return value and put that into an SNS topic, which is a notification, simple notification service. It can put that response into a queue. So all of these integrations are available directly from Step Functions as well. And if it's easier for you as an applications developer, you can think of it as like the main function of an imperative program, or a procedural program, sorry, that runs top to bottom, right? It calls out to each individual function along the way, orchestrates the behavior of those functions, handles the state as it passes through, and then terminates. And then, as I mentioned, it also handles error handling and retries and back off. So for a specific example, we have the AWS Backup DynamoDB rotator. This is available on GitHub, both the source code and as a serverless application repository application, which means you can deploy it immediately into an AWS account. Like I said, it's also available under the Apache 2 license, which means if you use a different service provider, you can examine the model, take it out, keep the code that works for you, get rid of the code that doesn't. If you want to use it for a different task, modify it as you see fit. So on the right, you'll see an example of a workflow or a representation of a workflow once it's been defined. The workflow is defined in what we call ASL, or Amazon States Language, which is a JSON-based state machine language. You define that inline, and I'll show you an example in a minute, but it automatically generates this visual representation for you, which means that you can take it to your management or to your customer, and you can say, is this what you think our process looks like? And you can iterate on that until you have an agreed process that they look at visually and it matches their business process diagrams or your IT process diagrams, but you also have that JSON process internally. And then you can get confidence that you're doing exactly what you want to do and that nothing is missed. On the left, you'll see the form of an input object, and this becomes the basis of your state. So your state, you can think of it as just one big JSON object that continues to expand as you pass through your workflow. So steps in your workflow can take data out of that state as you pass it to them, and I'll show you an example of this, and then they can put their return values back into that state to be consumed downstream. To walk through how this example works, AWS Backup is a managed backup service that works with RDS, DynamoDB, EFS, some other solutions. And when it completes its backup, in this case of a DynamoDB table, it dispatches a backup completed event to Amazon Simple Notification Service, to a topic. There's a Lambda function that's subscribed to that topic that receives that notification and kicks off the Step Functions workflow. And then that Step Functions workflow uses another Lambda function to restore that backup to DynamoDB, and then begins that cycle that we talked about of waiting and retrying until it's complete. And then finally, when it's complete, if you define an SSM parameter here, a system store parameter, then it will redefine the value of that parameter to point to your new resource. So this can be a Route 53 record as well. If you have like an RDS database that you want to restore, that you always just point to staging.companyname.com. You can redirect that record daily as you restore the new backups to it. Same thing with the table. So if you have applications that are pulling the value of their DynamoDB table from Systems Manager, then you update the value of that to point to your new one. The code is available at this URL, the full code. This is just an excerpt showing the basic version. I took out the test information of the handler. And this is a single step along the way. So if we look back here, this is this check restore status step. And you can see that these functions are very straightforward, right? Your input is a restore table from backup output type that's already defined for you. And the key that we're concerned with here is the table name in the table description from that input. And we provide that as the input to the describe table function. And then later down here in the output, you check the status of it to see if it's restored or if it's still in progress. And then you return that back to the function. And then this is a, again, shrunk view of the definition of the state machine, showing you only that step. It's a task step, which means it's going to execute something. This resource is the function that it's executing. It's an ARN, or Amazon Resource Name, which is a globally, across all of AWS, unique identifier for your Lambda function. The input path, this is a JSON or JPath that in the state tells you to take the top level object restore table from backup output, which was of type DynamoDB restore output, and you pass that in. So you notice that matches this input type here. We expect the input type to be a DynamoDB restore table from backup output. And then the result path is where we take the result returned from the function and store it in our state. So we store it in describe table output. And then the next step is the restore complete, which checks and then completes the loop. So we're just overriding this describe table output over time as we go. So again, if you go to this repository link that you have here, you'll have the complete version of this. You'll have the complete definition of this state machine. And this is essentially do whatever operations task you need to do, wait for it to be completed, see if it's complete, or check if it's complete. If not, loop, do any updating that you need to do, and then end. And that works across all three of those use cases. You just need to pull that out and put whatever individual functions you need in there to support that use case. And then you see this hanging off the bottom here, this error. This is simplified, but you can build that out as much as you need to. Whether you want to dispatch those errors to a queue, to a dead letter queue, to an email topic, to an SNS notification topic, however you want to handle them, it can be handled down there. So, thank you all for coming. Thank you for your time. I hope you find this useful and you can take it away. This is my Twitter. Again, I publish everything from my team on serverless resources. I tend to publish the most ones on Go. My DMs are open if you have particular questions about this presentation, this workshop, step functions, Lambda, whatever you need. If you have feature things that you want to get back to our teams, please let us know that as well. And I would greatly appreciate it if you could take a survey for this session. It's 3 questions, no personal information. It will take you 30 seconds, I promise, but it helps us improve the quality of our content, and it would mean a lot to me. So, thank you. Questions? I saw you first.
Could you pop up the slide if you have the
Yeah, of course.
So on this handler source code, how do you unit test that source handler if you create a session for DynamoDB inside the handler? How do you unit test that?
Who asked me for that? Did you get this copied? I'm going to move back to the source code. Oh, on this one? So I've removed it from here, but it's the same thing. And I'll go back to the other code to show you. But this goes inside an if guard. So you check. Notice this one doesn't have the receiver type here. So you'll put the receiver type there. And in that receiver, you have all of your dependencies. And you'll check, is this DynamoDB type nil? If it is, that means it's a live application. And so you need to create a new session and create a new DynamoDB service type. This is memory munging, so this is a very low-cost operation. It's okay to run every time inside your Lambda. If it receives a DynamoDB type in those dependencies, then that means you've passed in a mock. It already has a DynamoDB object, and it doesn't need to create one. So in this case, it's a step function, but just replace this with DynamoDB interface.api. And then you see it's checking with this guard here. If it's nil, initialize an actual client, go through your workflow.
If you initialize locally this client to DynamoDB this session, won't it fail? Because it will require some credentials for the AWS, like token ID and stuff like that.
Right. So if you're logged in, it won't fail because you'll have credentials, right? And
Okay.
that's where you get to. It depends, but
Yeah, but
this
you cannot run this on CI because then you have to be logged in all the time. Because mocks allow you like not to log in, not to do anything, and mock stuff.
right. So if you're running it in CI, you would run the test, right?
Yeah.
And if you run the test, then you're passing in the mock.
Okay.
So the only code that you're skipping in your CI environment is this guard that initializes the DynamoDB object.
Yeah.
So this over here is what would execute in your CI/CD environment. And then, yes, you don't have to pass in AWS credentials to your CI/CD environment to test it.
Okay.
Someone over here was next, I think. Questions? Right here.
Thanks, Rob, for a really interesting talk. If I understood correctly, you mentioned about retries and backoff and not having to write that manually in your code. I wondered if you could explain a little more about that, or is there an example of that in this code?
There is not in these slides, but yes. So here we do error handling without a backoff. And that's where you would do this. Here, again, we've done this manually with functions, more in order to demonstrate the functionality of making the API calls. But when you look at the definition of the state machine, it will look exactly like this. So states is just a set of state objects. One of those states is of type retry. One of those states is of type wait. So in there, you specify your backoff factor, which is typically 2 by default if you don't specify it. You specify your upper bound for your backoff. So maybe if you get to 1,200 seconds, right, that's 20 minutes. Maybe you don't want to go beyond that. You specify that in there. And it's from the perspective of your state machine, it's just another state. Anyone else? We have, repo there. Okay.
Great, thank you.
Super. Thank you all.